Earth's climate is changing. It's getting hotter and hotter around here. We need to find ways to slow or even reverse global warming. So please consider the following. The sun provides the energy, the heat and light that enables living things like us to stay alive and thrive. Sunlight beams through outer space, passes through Earth's atmosphere, and warms the land and ocean down here. At the same time, heat and light from Earth's surface is radiated or reflected back into space. For hundreds of thousands of years, the amount of energy coming in and energy going out has remained in a nice balance. But lately, over the last 2 centuries or so, Earth's heat balance has gotten out of balance. First, certain gases in the atmosphere, what we call greenhouse gases, trap heat. It's like leaving a car in the sun with the windows rolled up. A lot of the heat that comes in doesn't make its way or radiate back out again. The car gets warmer and warmer. Second, these days, Earth's surface isn't reflecting as much sunlight as it used to. It's like a car with a black roof versus one with a white roof. Cars painted black get warmer on a sunny day than cars painted white, even if it's cold outside. Ice and snow, cold as they may seem, reflect a lot of sunlight back into space. But when ice and snow melt, they leave darker land and sea surfaces, which absorb more heat than they did when they were white or nearly white. Speaking of white and reflecting light, there's a handy science term to describe how much sunlight bounces back into space. Albedo. It's from the Latin word for white. Albedo is a fraction between 0 and 1. If an object absorbs every bit of sunlight that hits it, we say its albedo would be 0. If it were to reflect all the sunlight that hits it, its albedo would be 1. Over the last couple hundred years, Earth has been absorbing more and more energy from the sun. Its albedo is steadily going down and down. As ice caps and snowfields melt, their reflective surfaces disappear. It's what we call a feedback loop. More heat, more melting, less reflecting surface. More heat, even more absorbing, even less reflecting surface, even more melting, and so on. When we turn natural landscapes into cities full of dark roofs and streets, it's the same feedback story. On average, natural land reflects 30% of sunlight. It has an albedo of 0.3. A blacktop road, on the other hand, absorbs a lot more heat than nature did. Its albedo is around 0.1 or 10%. As we pave over so much of our planet, a lot more heat is staying down here in the system. But we can flip this script. What if we used materials that reflect sunlight instead of absorbing it? Enter cool surfaces. Cool surfaces are exactly what they sound like. Materials that stay cool by reflecting sunlight. Instead of a scorching blacktop road reflecting less than 10% of the energy that hits it, a cool, pale pavement can reflect 2 or 3 times that. Cool surfaces are not complicated or expensive. Many of these materials are already out there, often looking just like the materials we use now, but way more reflective. Cool roofs can cut down the so-called solar heat gain, which means less air conditioning and lower energy bills. Cool, pale pavements are already cooling neighborhoods in the US, Japan, and Australia. They also chill our planet by reflecting more sunlight to outer space. Imagine this. If we replaced 80% of roofs and pavements in US cities with cool materials, it would offset the global warming produced by up to 12 years of the country's greenhouse gas emissions. 12 years! That's why it's time to go big. Cool surfaces aren't just a local fix, they're a global game changer. Together, we can reflect more sunlight, balance Earth's energy, and create a brighter future for all of us. Thank you for joining me on Consider the Following.